Hello everyone, myself Nitin Prakashrao Patil. I am assistant professor in Department of Computer Science, Savitribai Phule University. So I am presenting this as a part of teaching challenge which is organized by ACM in Compute 2022. My topic is teaching deadlocks with experimental demonstration. Now, the agenda that I am going to use or follow rather for this presentation, I will first try to revise few concepts of isolation, deadlock, and we will try to see the necessary conditions that are required for a deadlock to occur. Once done, I will try to practically demonstrate deadlock using PostgreSQL. Now, I am assuming few prerequisites over here for the listeners who would be listening to this or who would be viewing this video. The first assumption or prerequisite is like I want the listener to have good hands-on with respect to SQL syntax and database concepts. Database concepts should be clearly known. Secondly, the basic concepts related to processes and or probably transaction or lock management should be known. Moreover, I expect the user or the viewer rather to have idea about how to make use of PostgreSQL using PSQL client. So, let us start. Now, let us try to first find out what exactly deadlock is. Now, in databases, what generally we know is a deadlock occurs when two or more processes have a resource locked and each process is requesting a lock on the resource that another process is already locked. Neither of the transactions here can move forward as each one is waiting for the other to release the lock. Now, to understand more about this, let us try to know first what are the four necessary conditions for a deadlock to occur. So, first, mutual exclusion, where one can see that only one process may use resource at a time. This is first necessary condition. Second one is hold and wait. A process may hold allocated resources while awaiting assignments of others. Thirdly, no preemption. No resource can be forcefully removed from a process which is holding it. Now, if we see these three conditions are necessary but not sufficient for a deadlock to exist. Now, if we want deadlock to take place, then fourth condition is always required, and that fourth condition is circular wait. Now, this circular wait is a chain of processes which exists such that each process holds at least one resource needed by the next process in the chain. Now, to address this, let us try to first understand what exactly the criteria Postgres applies. For that purpose, let us revise what is isolation. Isolation is a property which controls how and when the changes should be made. Moreover, when exactly they should be visible to each other, probably users and or systems. Now, PostgreSQL achieves this isolation using MVCC architecture, multi-version concurrency control. Now, this is a technique which allows sessions to access the same record concurrently. For example, there is a session 1 which is updating a record. I want session 2 to still have an access of the record. Now, let us try to understand few scenarios. What happens if at the same time both session 1 and session 2 wanted to update the same record? Second, one executes truncate table command from session 2 when session 1 is accessing that table, and third one executes vacuum table in session 1 while through the transaction accessing the same table in another session, that means session 2. Now, to overcome this particular problem, what Postgres uses locking. Now, how locks are used? So, to permit this concurrent access or maybe modifications for the database objects, locking would be useful by issuing a lock once a valid SQL command is executed to PostgreSQL server or on PostgreSQL server. This lock type would be decided depending upon what kind of command is executed, what type of command is executed by the user. Now, to demonstrate this scenario, I am making use of two relations, and I am creating a scenario where I am trying to access these relations across two different terminals, terminal 1 and terminal 2. The first relation is student, the columns are roll number, name, gender, degree, and second relation is subject, subject code, title, credits, number of credits for that course or for that subject, and the degree that the subject belongs to. Now, here I have added or inserted some records into these relations. Now, let us try to see what exactly happens when we execute same thing on Linux platform. Let us start this demonstration. So, for demonstrating this, I am using Ubuntu operating system. Now, I have opened two terminals. Now, from both the terminals, I am trying to access the server, Postgres server. Say I wrote PSQL, I am using PSQL client. So, PSQL. So, let me clear the screen. Now, let me initiate the transaction. So, to initiate the transaction through PostgreSQL, I have to write begin. So, same thing from the another terminal, I am trying to initiate the transaction number 2. Now, terminal 1 has one transaction, terminal 2 has another transaction. Now, from this terminal, let me fire an update command. So, I am writing this update subject set credits equal to 3, where subject code is CS101. Say I have fired this query. Now, one may see here that my update got executed. Now, if I try to access, say select star from subject, where subject code equal to CS101. Now, one may see here like what are the number of credits I updated, that can be seen over here. Now, let me try to access student relation from this particular terminal or from this transaction. So, let me take this update student. Okay. Now, I know that for this particular roll number 22109, I have taken gender as female. Now, I am firing an update command for the same student. Okay. So, if I try to see select star from student, where roll number is equal to 22109. Now, I can see this. Now, we are sure in this case now inside the transaction both the queries related to update are executed. Now, what I am doing is from this terminal now, this terminal number 2, I am trying to update again a query, I am going to update a record which was available for this. Okay. So, let me fire update command again, update subject set say credits equal to 5. Now, instead of 3 I want to make it 5. So, where subject code is equal to CS101. Now, if this query is syntactically correct and if there is no error with respect to the query, this query should get executed. Now, when we, this is our assumption that this query should get executed, but if this query is correct and as this particular terminal already had a lock on that row, so you may see that it is waiting for some time until unless the lock is released through this terminal for this particular record. Let me do the same thing because we want to achieve circular wait. Let me do one other thing from here, from terminal number 1. Let me try to update relation student, update student set say for example roll number is equal to 22108, where roll number is equal to 22109. Now, when I fire, after some time, let us see what exactly happens. So, what I will do is I will try to increase this size. So, let me execute this command. Now, with assumption that this query is syntactically correct, okay, and even the attributes that I used and the data that I am trying to work with is proper. Now, we know that this 22109 record for that roll number is already under control of this terminal, another terminal here, correct, and for which we fired an update query. Now, when I fire this, now it is like the lock was with the other terminal and you are trying to access the same thing. What is happening here too, correct? So, we are trying to update subject, but the lock is under control of this other terminal. So, when I fire this command now, let me fire this. Now, one may see here that the timeout happened. After that timeout, which is a configuration parameter in the PostgreSQL configuration file, what happened is it is showing us after that timeout one of the process got aborted. Now, this terminal got aborted. Instead of terminal, let me say this process got aborted, correct, and that is the reason why it is showing us the error deadlock detected, correct. And ultimately, one may see when the deadlock detected error is shown, the terminal which was having access to this subject table or subject object here, okay, this got released automatically, and that is why this command got executed, correct. Now, let me open another terminal and try to show you how this PostgreSQL configuration file or a Postgres server configuration stores the log. So, the log is stored in var log / PostgreSQL. So, let us open that log. So, less PostgreSQL. Now, one may see here that if I go below, the recent log which is stored there. So, one may see here the same thing which we saw there on the other terminal. So, let us see, say for example this. So, if I open this terminal, one may see here 7643 waits and so on. So, this kind of error is shown. So, I can see the same thing 7643 waits here lock, correct, and that is how it is storing that inside the log as well whenever this deadlock detect error occurs. Now, towards end of this session, I want to add a few things as in a closing notes. What we saw here is now circular wait scenario, which we demonstrated by making use of PostgreSQL, where we have seen that it is leading towards deadlock. At the same time, we tried finding out what are the deadlock detected message was shown to us on the terminal. Similar thing is recorded in the logs too. Now, as per my experience, instead of just theoretical explanation, this demonstration definitely helps the students to see really how deadlock occurs. And this is like since 2011, I am doing the same kind of, or I am following the same kind of approach to demonstrate majority of concepts in databases like this. Thank you very much.